Anytime you get antagonist versus agonist, whatever questions, go straight to the graph. Draw a finish line. You can see that morphine drug X finished at the same time. Well, a competitive antagonist will compete and be a competitor, so it'll finish the race first. So if you have one drug and a finish line right here, well then a competitive antagonist will be closer and cross the finish line first. Well, the lines don't look like that, so you can rule out competitive antagonist. I haven't seen anything on UWorld or AMBOSS so far dealing with full agonist and inverse agonist, and first aid only deals with these three options, so you can strike those out already. These two look the same, so they're both going to have a line like this and a line like that. They finish the race at the same point. The y-axis right here is dealing with efficacy, and the x-axis is the dose. This is important because dose is inversely proportional to potency. All that means is when one is high, the other one is low. So if you have a higher dose, then it's a lower potent drug. Or if it's a low dose, it's a higher potency drug. So looking at competitive antagonists, the only thing that's changed is not the y-axis, but the x-axis. So the dose is increased, and that means that this drug, this competitive antagonist, has a lower potency. Now, non-competitive antagonists and partial agonists, they have the same lines. They finish the race at the same time. The only thing that changes is the y-axis. The efficacy will be lower. So how do you distinguish between non-competitive antagonists and partial agonists? Well, non-competitive antagonist acts on not the same receptor. Partial agonist acts on the same receptor. If you read the stem, you have drug X, it binds to the same receptor, finish the race at the same time. I know I have a partial agonist.